Trigonometric functions with general angles. So if we look at this angle right here, and we know that point P is contained on its terminal side, we can say things about this. So just like in a unit circle where we had a radius, we can talk about a radius in a bigger circle, in a circle that comes all the way out to xy, where the radius can be any number of things. So we could take that and spin it around and make another circle. So let's look at what that does to our trigonometric functions. The radius is always going to be positive. However, x and y are going to change as they go around the coordinate plane. You can find r by using the Pythagorean theorem. This is a right triangle. X squared plus y squared is equal to r squared. When we look at this, we can define our trigonometric functions in accordance with our y coordinate, our x coordinate, and our radius. So if we look at that and how it relates to this triangle, sine of theta is the opposite, y, over the hypotenuse, r. In our unit circle, r was 1, so sine theta equaled y. This is not the case if our radius isn't 1. Cosine equals the adjacent, x, so that's our x coordinate of our point, over r. In our unit circle it was 1, but in this one it doesn't have to be. Tangent is the opposite, y, over x. Y over x, given that that point is on there. Cosecant is just the reciprocal of sine, r over y. Secant is just the reciprocal of cosine, r over x. And cotangent is just the reciprocal of tangent, or x over y. So given that point, we can calculate the radius and come up with all of our trigonometric functions for a circle with any radius. So let's take a look at an example. So if we want to find values for sine of x, cosine of x, and tangent of x, if the terminal side of this theta, of our angle theta, is in standard position, which means it just goes counterclockwise, and contains the point P, our point P is going to be 5, negative 3. So first I'm going to plot the point 5, negative 3. 5 on the x-axis, 3 on the y-axis, and I'm going down here. Remember, our r is always positive because it's our radius. We can calculate our r by using the Pythagorean theorem. So r squared is equal to 5 squared plus negative 3 squared, which distance is really positive. So when we're calculating our distance, we can really use a positive 3 here. It's not going to matter because we square it, but in the position, it's a negative. So r squared is 24, and then I can find r is equal to 2 rad 6, just reducing that a little bit. And now I can use my trigonometric functions to find sine, cosine, and tangent of theta. Sine is equal to the opposite, 3, and it's going to be a negative 3 because of its position. It's in that fourth quadrant, over 2 rad 6. Cosine of theta is going to be 5, or the adjacent, over the hypotenuse, which is 2 rad 6. Tangent is going to be opposite, negative 3, over 5. So tangent is negative in this case. Given that secant of theta is equal to 3 over 2, and that theta is in the fourth quadrant, that's going to be important, what is tangent of theta? So in the fourth quadrant, over here, I know that my sine is going to be negative. So all of my y values are going to be negative, and my x values are going to be positive. Now that's important. We need to know where this is at. So even though my secant is positive, I know it's in the fourth quadrant. So secant is just my hypotenuse over adjacent. So my hypotenuse has to be 3, and my adjacent has to be 2. And I can calculate my opposite over here. So when I calculate my opposite, I just use the Pythagorean theorem, where I have 2 squared plus b squared, pretend like I don't know this yet, plus b squared equals 3 squared. I go ahead and solve for b and I get square root of 5. Now I have to realize that's going to be a negative square root of 5 because it's in my fourth quadrant. So I know that's going to be a negative number. And I know my x value is going to be positive. So because it's in the fourth quadrant. And now I can go ahead and calculate my tangent. And that's just opposite, rad 5, over adjacent, which is 2. And it's negative, negative rad 5 over 2. And that tangent should be negative in that fourth quadrant because I have one negative and one positive that I'm working with. So depending on what quadrant depends on what will be negative. So state whether the value of each function is positive, negative, 0, or undefined. So if I have a cosine of 150 degrees, I want to visualize where that's going to be. I know this is 180 degrees and this is 90 degrees, so it's somewhere in this second quadrant. Well, in this second quadrant, cosine is my x value, and so it's going to be negative. I'm on this side in this second quadrant. So this is actually a negative. Negative 3 pi over 4. So here I have 2 pi over 4. Here I have 4 pi over 4. Negative 3 pi over 4 is going to be right in here. And I know here my sine am below the y-axis, so it has to be negative. Tangent of 5 pi over 4. So this is 4 pi over 4. Here's 5 pi over 4. And my tangent right here is in here. And my sine and my cosine are negative, my x and y values. So when I divide them, I get a positive number. So tangent of 5 pi over 4 must be positive. Tangent of pi over 2. That's up here, pi over 2. My coordinate values, remember, are 0, 1. And so if I have 0, 1, I'm dividing my y by my x, so 1 over 0. So that's going to be undefined. Looking at my cosecant of negative pi over 2, I go down here, negative pi over 2, and I want to look at, cosecant is just 1 over sine, and my sine over here is going to be negative in here. And it's not going to be 0, so it's negative down in here. It's at negative 1 actually. Secant of negative 270. So I'm going to go clockwise all the way up here. So this is 180 plus another 90 is negative 270. That's up here. And secant is just 1 over cosine. Well, cosine is 0 up here. I'm not going either way. And so 1 over 0 is undefined. So it's really important to look at the quadrant you're looking at and how far over and what point is contained when you're looking at trigonometric functions of different angles.